Welcome to Brain Vision.
A barrel of diameter 134.122 centimeters at 20 degrees is to be enclosed by an iron band. The circular band has inside diameter of 134.11 centimeters at 20 degrees. It is 9.5 centimeters wide and 0.65 centimeters thick. To what temperature must the band be heated so that it will fit over the barrel? What will the tension in the band be when it cools to 20 degrees Celsius? Okay, so for the first bit, we need to start from our thermal expansion formula. So delta L over L is equal to alpha delta T. And so rearranging this, delta T, so our change in temperature that we require is equal to delta L over L, alpha L, like so. Alpha for iron is 1.2 times 10 to the minus 5. Delta L is simply 134.112, subtract this, and our length is simply our original length, like so. So delta T is equal to 0.00012. So that's 134.122 subtract 134.11 divided by alpha, which is 1.2 times 10 to the minus 5, 1.2 times 10 to the minus 5, multiplied by the original length, which is 134.11. And plugging this into a calculator, we get the delta T. So this is the answer for part A. Delta T is equal to 7.46 Celsius. Cool. And so going over for page 2, for part B, sorry, even. Part B, we are going to say, it would start from the formula for thermal stress. So thermal stress is equal to Young's modulus times by coefficient of linear thermal expansion and change of temperature. So change of temperature is simply equal to minus 7.46. Alpha of iron, is equal to 1.2 times 10 to the minus 5, and we have Young's modulus of iron, which is equal to 2 times 10 to the 11. And plugging this all in will give us sigma, the stress is equal to minus 1.79 times 10 to the 7 pascals. So one thing to note here is that when calculating the tension in the band and the pressure, so one thing to note here is that we actually have, so naively, naively, if we had a straight bar, it would only be connected once through. So when thinking about what tension would be, however, given that we are connected twice because it's a circular band, so it comes back on itself, it means that when calculating the tension, we then have to divide by 2. Using our formula for tension, so stress is equal to stress times cross-sectional area is equal to tension, or the force in the band. But because it's because we have a circular band, we need to divide by 2 because we're connected twice. So the force is distributed, if you like, around 2 connections. So if you take a cross section of a band, you see that there's two connections going on. So yes, we have to divide by 2, but I would note that this is just for a circular band, so normally you just multiply by the cross-sectional area for a band. And so we see that multiplying this in here, the area is given by, so we can calculate area, so 9.4 centimeters and 0.65 centimeters. So area using SI units, System International units. So in terms of meters, we have 9.4 times 10 to the minus 2. And we multiplied by 6.5 times 10 to the minus 3 meters. And substituting this area into this equation and sigma into this equation, we see that force is equal to just double check this. So plugging this all into a calculator, we see that it's equal to two significant figures, 5.5 times 10 to the 3 newtons. And just to quickly note here before finish, pascals is equal to newtons per meters squared.